There is a machine sitting in a pit right now that most people will never see. It weighs over 1 million pounds. It stands 5 stories tall. Its bucket is big enough to swallow a school bus whole. And when it scoops up rock, it picks up 120 tons in one bite, then swings around and drops it into a truck the size of a house, all in under 30 seconds. This is the P&H 4100 electric mining shovel, and for decades it was the single most powerful digging machine on Earth. If you have ever turned on a light in America, there is a real chance that this machine helped make it happen. It dug the coal, it uncovered the copper, it stripped away millions of tons of rock so that mines could reach the minerals underneath. It is one of the most important machines ever built, and most people have never heard of it. This channel breaks down the engineering and economics behind the machines that shaped the modern world. Subscribe now because we go deep on this every single week. Let me show you how this machine works, and why it is slowly losing its place in the world. How it works. The idea is simple, even if the machine is enormous. A thick steel cable wraps around a giant spinning drum. An electric motor turns the drum. The cable pulls a huge steel bucket, called a dipper, up into a wall of rock or coal. A second cable pushes the bucket forward, forcing the teeth on the front edge to cut into the material. The bucket fills up. The whole machine then swings around and dumps the load into a haul truck waiting alongside it. Then it swings back and does it again. The machine is powered by electricity fed through a thick cable that trails behind it across the mine floor. That power comes from the national grid, the same grid that powers your home. And because it runs on electricity instead of diesel, it can run all day, every day, for 30 or 40 years. At full speed, one P&H 4100 can load a 120-ton truck in under 30 seconds. It can move over 60,000 tons of rock in a single day. Nothing on Earth moved more material per dollar than one of these machines working a good coal seam or copper ore body. Why it dominated? Open pit mines have a problem. The useful material, coal, copper, iron ore, is buried under mountains of worthless rock. Before you can get to what you want, you have to move everything sitting on top of it. Sometimes that means moving 5 tons of waste rock just to get 1 ton of ore. When you are moving millions of tons of rock every year, the cost of each ton matters enormously. The electric rope shovel had a massive advantage here. It runs on grid electricity, which is far cheaper than diesel fuel. It runs continuously, 24 hours a day, with very few stops. And its cycle time, the time it takes to fill one truck, is incredibly fast. Mining companies built entire operations around these machines. The Powder River Basin coal fields in Wyoming, the giant copper pits of Arizona and Chile, the iron ore mines of Western Australia, all of them built around the rhythm of the rope shovel loading trucks, shift after shift, year after year. At its peak, the P&H 4100 series had no real competition for large-scale open-pit loading. It was faster, cheaper per ton, and more reliable than anything else available. The machine was king. The cracks begin to show. But even at its peak, the rope shovel had a problem that would eventually cost it everything. It could only work in one direction. The machine digs forward into a wall of rock. That is all it does. It cannot reach above itself. It cannot dig below where it is standing. It cannot follow a narrow seam of ore running at an angle. And it always has that cable, a thick, heavy power cable dragging behind it everywhere it goes, getting run over by trucks, getting damaged, needing workers to move it every time the shovel repositioned. Repositioning a rope shovel is a slow, expensive process. The cable has to be moved. The machine crawls on its tracks. Electricians have to reconnect the power supply. What takes a rope shovel hours to do, a different type of machine can do in 10 minutes. That different machine is the hydraulic excavator. And while rope shovels were dominating mines in the 1980s and 1990s, hydraulic excavators were quietly getting bigger, faster, and more capable with every passing year. The new rivals. Machines like the Liebherr R9800 and the Komatsu PC8000 changed the game. The Liebherr R9800 weighs 800 tons, runs on twin diesel engines producing over 4,000 horsepower, and has a bucket that holds 45 cubic meters of material. The Komatsu PC8000 is similarly sized, with a 42 cubic meter bucket and more than 4,000 horsepower on tap. Where things stand today, the rope shovel is not dead. The P&H 4100 is still being sold and still being used in large mines around the world. Some operations, particularly in oil sands in Canada and copper mines in Chile, still find that the electric shovel's raw output and low cost per ton makes financial sense for their specific situation. But no new mines are being designed around rope shovels. No new generation of young engineers is drawing up mine plans that depend on them. The hydraulic excavator is cheaper to buy, easier to fix, more flexible in the pit, and far easier to connect to the automated systems that the industry is building toward. The P&H 4100 helped power the 20th century. But the 21st century mine is being built around different machines, and that gap is only getting wider.